All right, here we go. Let's start off with today. We're going to get away from the proofs and really go to something you probably did in 7th grade, I think, maybe 6th grade, I don't know. And that is when I put a triangle on a graph, what could I do with that triangle and not affect its size or shape? All right. First thing I could do is I could flip it. Does everyone agree if I flip a triangle on a graph, it's still that same triangle? I didn't touch its size or shape. We're all in agreement there? All right, I'm not a big fan of the word flip because we are in honors math and I'd like to use the actual vocabulary. All right, flipping is the term for reflecting the triangle. All right, so reflection, I wouldn't change the size or shape. What else could I do to this triangle? Why don't I just put one up here? We can, okay, I could turn the triangle. Would that affect its size or shape? No, it would not. All right. Turning it is another name for rotation, okay, which is the third one here. And the third thing I could do to this triangle on a graph that wouldn't change its size or shape is slide it up, down, left, or right. All right. Slide, another name for translation. All right. So these three, reflection, translation, and rotation, we group together and call them what's up top of the page, which should be rigid motions. All right. All three of these are referred to as rigid motions. A rigid motion is some type of transformation that does not change the size or the shape of the figure. All right. You probably did a fourth one too in the middle school. That is not up there. A dilation. Why is a dilation not up there? Because a dilation made a figure smaller or bigger. It enlarged it or reduced the size, and that obviously would make it not congruent to the original. All right, so any rigid motion will not change the size or shape of your original figure. All right, and the three common ones I want you to be familiar with: reflection, translation, rotation. Okay, we refer to them again as rigid motions. All good there. Okay, I pray. I can start. Thank you. All right, let's move on. All right, so real quickly, can we identify what type of translation is going on here? All right, what type of translation do I have going on from the blue to the green or the green to the blue in my case? All right, this first one here, how do I go from one figure to the other? Do I have to reflect it, slide it, or turn it? Reflect it, yep. And I'm not going to spend too much time on this because after the midterm, we do a whole unit on the reflections, translations, and rotations. What about these two trapezoid-looking figures in the second one? That's a rotation. All right, rotation. And then how about the last pair that I have up here? That would be a translation. Yep, all I'm going to do is slide, and the sides would match up to each other. All right. What I want to do with you, though, is show me that a rigid motion is going on. Prove to me that a rigid motion is going on. All right, so I will give you a second to copy triangle XYZ and ABC. All right, first thing, and you don't yell anything out because I'm just going to start calling on some people. What is the transformation from ABC to XYZ? All right, what is the transformation that I'm performing? Here we go. Let's start it off with 23. What's the transformation I'm performing? It is a reflection, yes. Verify that this is actually a rigid motion. If it truly is a rigid motion, the original and what I end up with should be congruent. How am I going to prove that they're congruent? Okay, they're triangles, right? How many methods do we have? How many methods do we have to prove these congruent? Okay, let's review here. How many methods do I have to prove triangles congruent? 5, right? Do we need to go over those 5? Okay. Other than side, 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 and HL, all of them involve an angle, correct? All right, and I think we talked already on a graph, it's virtually impossible unless it's a right angle to show that angles are congruent. So really, I only have one method, side, side, side. And how do I show the corresponding sides are congruent? Distance formula, all right? I'll make this one easy on you here. Every group will take a side. So let's start with triangle ABC. Can you guys here find me the side length of AB? This group right here up in the middle, can you find the side length of BC? You guys over near the door, you're responsible for AC. Simplest radical form, please. All right, and then we'll compare that to triangle XYZ. XY, can I get you guys to do XY right here? XZ. Let's go group over there, please, near the books. XZ, and what do I got left? ZY. Group over there in the corner. You guys will coming up next one. All right, you guys will be coming up for the next one. Don't worry. And again, reminder, distance formula, D equals, so we all are on the same page, square root x2 minus x1, all squared, plus y2 minus y1, all squared. Find your specific distance, confer with your group. Simplest radical form if possible. One of the sides in each triangle should be simplified into simplest radical form. We ready? Okay, what do we got for AB? AB? Square root of 17, everyone. Here we go. Let's start copying it down if you weren't responsible for it. Radical 17. BC. Square root of 29. And AC in simplest radical form. 2 radical 10, correct. You should have gotten 40 for that. And that broke down to 2 radical 10. XY. 2 radical 10. Oh, I got one pair congruent. Let's hope the other pair are. XZ. 7. Radical 17. Got another pair congruent. Perfect. And then how about ZY? Radical 29. Perfect. And usually when we're working on a graph, the work's beautiful, but I still need some kind of concluding statement telling me why they're congruent. All right, so if I go triangle ABC, we're still not done with the work yet. What would be a correct one to match up all the sides? Because you would think it was XYZ, but it's not. What did AB match up with? XZ, right? How about XZY? Does that match up? Let's see, AC and XY, yep, looks pretty good. By what method? Side, side, side. And that's all I really need. Rigid motion does not change size or shape of the original figure. Everybody good? We're all good? Okay, I do want to practice one more with you. First thing I'll need is the transformation that had just occurred. Okay, we have it graphed. How do I get KLJ on the PRQ? 7. Rotation, yes, rotate it around. All right, same thing. I'm not going to make you guys do 6 distances. I'm not interested. All right, I'm hoping at this point you guys can do distance formula. Okay, here we go. Group in the middle, the back there. You guys got KL. Corner group over there, you got LJ. Here we go. Group up front, you guys have KJ. You guys, PQ. Group over near the door, QR. And we'll go to that group there, PR. And 2 of the sides should be in simplest radical form. KL, your group ready to go? KL, what do you got for me? Radical 17. Yep, square root of 17. LJ, what do you guys have for me? Yep, 2 radical 5. That would be the square root of 20 broken down. KJ group, what do you have? 3 radical 5, square root of 45 broken down. Perfect. Let's hope they match up. PQ, what do you got for me? Three radical 5, yep. How about the QR group? Radical 17. And PR? There we go. Perfect. Everything should match up, which it does. So give me a little statement right now. KLJ, congruent to, I'm going to call in some somebody here. Make sure the sides match up. KLJ. You're up, 23. QRP. How did we do there? KJ and QP. Looks pretty good. Bye. Side, side, side. Usually, this would be at the time and point you could go onto your homework, but as you know, we don't have homework this weekend because of yesterday. So what I'd like you to do is go back to page 41. And we're going to end this with a single person group proof, however you want. All right, go back to page 41 and try out 2 right now. I will walk around, help you out, and if you want me to look at it at the end, I certainly will. All right, this one is a challenging one, so take your time, please. Take your time. Again, the no homework is for period 1 only. Period 2.